What is up, everybody? It is Jason Watts, AE, your friendly neighborhood Siemens automation engineer. So welcome to the stream. It's been a little while. We've got some longtime members in the chat. We've got AKD in there too. So chat, we've got some honored guests in chat. The orange star means that these members have been members to this channel for over a year, and I cannot believe that lasted for a year, and we're still doing this. I love doing this content. If you don't know who I am, my name is Jason Watts. That's the channel name. I am the CEO and founder of a little automation company out of Tuscaloosa, Alabama. But I am based today in, the name of that company is Alpha Industrial Technologies. So if you see all the wolf logos and kind of wolf stuff, that's because it's Alpha Industrial Technologies is my company. But company's out of Tuscaloosa, Alabama. I am located here in Atlanta, Georgia, and we are streaming from the lab in West Midtown, Georgia, just west of Georgia Tech. So there's a lot smarter people just a little ways down the road, down that way. Alpha Industrial Technologies is my company. You can look us up on LinkedIn. We got a little page there, and if you can look me up as well, I have a defining feature in my profile picture that makes sure that you got the right Jason Watts. But yeah, anyway, we've got a cool thing today, because if you don't know who I am, I've got about 25 years of experience working with Siemens drives and Siemens automation technology. And yes, that's right, I'm a redneck from Alabama that uses German technology. And so, it's kind of crazy. But coal miner family, kind of, that's why I call it the rednecks, and kind of proud of it too. There's a lot of hardworking people out there in industry and automation. And yeah, we've got some cool stuff today because we're talking about drive topics, and specifically we're going to be talking about some motion control topics using the 1500 TF processor and inside of TIA Portal. And this is not going to be an introductory course whatsoever. This is very much going to be an advanced motion control. I call it 102, but it probably should be like 300 because we've got a lot. I'm going to type in chat here. So, we've got more orange stars. We've got some of the OGs to the channel in here today. Alpha Industrial .test. So AKD, the PID, we could definitely talk about the PID at the end of the stream, but yeah, we've got a lot of stuff to talk about today. I have a couple of videos on the compact PID. We've got one of our members asking about some PID control. There was a discussion about things in the Discord channel. If you are not in the Discord and you're watching this, we've got a bunch of engineers that are working together, solving problems, kind of like designing systems and things in our Discord. And there were some questions about some PID controls, and I'll definitely go through the kind of like concept of the PID later. But I definitely have talked about that in a couple other videos, specifically the PID compact. So that is a Siemens basic PID controller, and it's pretty good. But I got a lot of stuff we need to get through today on the live stream, and the way these live streams work. If you're watching us live, welcome to chat. Say hey in chat. But you will be getting access to the whole chat, or the whole live stream. The stuff that we do on motion control will be available. This live stream will be available like as long as, I guess, as YouTube is around. but I'm going to trim off the bonus section at the end, and eventually we will make that bonus section members only content, just so that it keeps all of our topics concise and SEO optimized. But yeah, so let's jump in, and I'm going to swap over to my portal here, and let's see, do I have my face? Can I get my face? Yes, look at that. So hopefully that doesn't cover up too much of the screens, and you'll see here in a second that we're going to be doing a lot, because we're going to be talking about virtual axes. We're going to be talking about the concept of virtual axes. We're going to be implementing a virtual axes on a real system. So as you can see there, I have a 1515. Here's the device, and it works here. I've gone ahead and cheated a little bit, because I thought that I was going to impress you by going through and setting up everything really fast and getting everything going really quick and it not really impact the live stream that much. Well, one, I realized that it isn't that impressive, because I mean, I've done that quite a few times, set up technology objects, set up drives, and B, it still took a long time. and we've got probably a good at least 2 hours of material that we're going to be going through on the motion control. So virtual axes, we're going to be doing absolute gearing, looking at some tracing on that sort of stuff, and then we're going to be doing some camming, and then we're going to be talking about all sorts of other stuff in the bonus time. So I've already got a little system here set up, and just checking to make sure that you can see everything and clear that out. So what we've got here is a 1515 TF processor. We're not going to be using the safety functionality, only the T functionality. Just if you're not aware, you do have to have a T processor in order to do all of the functions. Well, not all of the functions. You can do a virtual axis on a regular processor, but you cannot do absolute gearing and camming. And so what we're going to do, and I'm actually going to bring up something that I actually forgot to set up here in a second ago. Where is it? Here it is. Is our little drawing thing. Let me make sure that I can draw. Y'all see that? Yes, sweet. Okay, got cleared and got me back to my thing. All right, so again, we're gonna be talking about these motion control topics, virtual axes, absolute gearing, absolute, and camming. So we've talked about in the Motion 101 class, we talked about gearing, and that would be synchronizing two motors together as if they were physically geared together. And we have a gear in function called MC gear in. And then that is what we talked about in that Motion 101 class. Here, we're going to be talking about MC gear in pause, so position gear in. Whereas the MC gear in just takes and doesn't actually locate via position. You can't do anything like phase shifting or anything like that. MC gear in just takes you, and whatever your leading axis is doing, it will just spin up and then move into your following axis, and you can have a gear ratio and everything. But I'm going to show you the difference between what we're doing with that. So a little bit more about our setup here. We've got a G120 with a CU250S with an encoder. So you can kind of see it. I'll click over here. You can't really see it, but there is an encoder on that G120, and you'll be able to see that wheel move. I've already got the 1500 downloaded with a basic program, and so we are we're going to be pulling in this here. and we're going through. I'll show you the basics program we have. We have a leading axis technology object, and I've gone through and just done the basic setup on it because we've gone through, and it took me a little while to tune to try to get the best out of this motor. This is a really old 4-pole motor that is, I guess, not the best of quality anymore, and so you're gonna see that motor kind of hop between at lower speeds. It's gonna kind of be a little bit jerky, but just know that I've worked in order to get it tuned as best as possible. Remember, this is a G120, so this is an induction motor, 4-pole induction motor. Very simple. But one of the things about doing these technology objects that we're going to be talking about today, you have to have an encoder. The G120 can absolutely do encoders. You have to have a CU250S. So I have a CU250S-2 Profinet version, and you can see that it is set up here with a standard Telegram 3. So the Telegram 3, it's a industry standard telegram, but it has the position feedback. So one encoder position feedback, that's Telegram 3. So that's what we're using today. So what we've got here is our leading axis is set up. I've done one thing on all of these, is I have disabled the following error, and following error is going to be one of the things that is going to trip you up the most in kind of getting these systems work. And following error, as you can see here, is it is the difference between the set point and the actual value. So if you have like this blue line here is the set point, is trying to ramp up, and for some reason your motor cannot speed up that fast, you have an increasing following error that will continue to get bigger and bigger. So that is what the following error is. And there's some threshold here that will fault out your technology object, and for our purposes, we don't need it. In a real system, you would want that because it signifies, hey, I'm trying to accelerate too fast, I'm under too much load, something like that. It means that you're not actually following how you were supposed to be following, and that'll be very important when we talk about virtual axes, because you're kind of assuming that your motor can follow as quickly as you are telling it to. So I've disabled following error on this. And again, I'll go through and explain some of these topics, or I guess terminologies and things like following error, and we'll have like standstill monitoring, some of the things like that. But in general, I'm going to assume that you've watched the Drives 101, Drives 102, Motion 101 classes, and so you kind of generally understand the concepts of drives and motors and encoders and things like that. If you're not familiar with those, you might be a little bit confused on the live stream, but there is a lot of information about that on other streams. So we've got that leading axis set up, and then in my program structure, I have a function call called leading axis control that I'm calling from my OB1. And this leading axis control has my basic MC power, MC reset, MC stop, and MC home for my leading axis. And so this is all of the stuff that you need to control a motor using technology objects. Every motor is going to have some version of these, especially we're going to find out later that we're going to need this MC home in order to actually get anything going. So I'm just looking at something real quick. My music seems different today. A lot of different results. Anyway, But what we have now is the second thing that we're going to be doing in order to move our leading axis. We're going to be using the MC jog, because one thing about a leading axis is, and especially the way we're going to be doing it, is it can be doing any number of things, but the concept that we're going to be doing is using what's called a virtual shaft, or a virtual leading axis. So a lot of systems will be looking at a master value, and then you'll have multiple motors that are all gearing onto that one master value. And so it kind of syncs up, and those multiple motors are kind of doing their own thing. And what's really cool is that there's an analog, like a mechanical analog system, that previously, before you had PLCs and all of this other technology and everything, you would actually have to mechanically link motors together. Because one of the coolest things that I've ever really looked at is a system that there's a very large house. It's Vanderbilt's, who was involved in railroads in the U.S. and like the early U.S. and he was kind of like the world's first billionaire sort of person, or at least in the U.S. And he has a house called the Biltmore, and it is just outside of Asheville, North Carolina. If you're here in the U.S., if you're not, who cares? It's kind of like a little castle, like a Versailles castle, just not quite as old. But in the kitchen of this Biltmore building, which was built in like the 1800s, there is like these big like mixers and pieces of equipment and things that they're using in this kitchen way back in the 17th century, or I guess the 19th century. And so and the way they do it is they have like a big steam powered drive that has like an actual coal-fired steam powered plant, and this powers a shaft that rotates. Well, if you have like a big mixer or something down here, what you would do is you would have a belt, like a leather belt, and there would be a pulley on this shaft, and then a pulley here on this shaft, and you would literally take and loop this belt over, take it physically and flip it over and lock it onto and pull it and lock it down, tension it down. And this large steam engine that was outside the building has powering this shaft, and then you can change, kind of turn on and off equipment, like, and then this would start rotating. Really cool. Cool thing about it, if you wanted to change the speed of this device, you would change the pulley. You would change that thing. And so what you would do is you have this like steam engine outside powering this shaft, and you would be gearing on and kind of syncing up and syncing off this all of your equipment. And you could have multiple of these pieces of equipment running off of this single shaft. And that is the concept that we're going to be doing, except we're not going to be using a steam power. We're going to be using a virtual leading axis for this. And we're going to base that off of a real leading axis. So the first thing I'm going to do is I'm going to show you, I'm going to clear this out, and I'm going to show you that we actually have control of this motor. And the way that I have a little data block here that I have just connected up the axis, jog forward, all the power resets, everything is connected up into a little data block that just has all of this stuff in it. And the reason why I put it into a data block is because in data blocks, if you didn't know, you can monitor them, and then you can just double click. First time you have to say yes, and you can't hear it, but I can. But back behind me, there's the motor is sitting there. So kind of look over here, and when we jog this forward, there you go. It's actually moving. Look at that, chat. I actually know how to turn a motor. I'm not lying to you. I have experiences. What's up in chat? If you're coming in, be sure to let everybody know that you're here in chat. And y'all, the more that you talk in chat, the more that YouTube loves this live stream and will start putting it out there. We've got about 10 or so people on right now, which is awesome. I love doing this, and this international crowd that we have is awesome. So we've got our motor here jogging, and pretty awesome. So I want to just show you. So that's the basics of what that's doing. And so that's moving at 360 degrees per second. And the way that you can set up that is just in the basic parameters of your technology object. I have this set up as a rotary axis in degrees per second, and then I have it moduloed out for 360 degrees, and we'll talk about why I do that here later on. But so we've got this thing going, and what I want to do is I want to show you real quick, because we're going to be using a trace function, how to set up. We're going to add in a new trace, and we are going to pull in. We're going to click on our leading axis, and you notice I have my details view pulled up down here. We want to pull in the actual, well, I guess our velocity. No, I want my position. Where's my position, chat? There it is. Our actual position. We're going to drag this in for the leading axis. So leading axis dot actual position. We're going to go to sampling, because this is very important. The technology objects, when they are running, they're being calculated in a object block or organizational block called MC servo. It is not main. Normally, if you're just running your regular block, you're going to sample your traces from main, because that's where all of your general information is getting calculated. Well, these technology objects are getting calculated in MC servo, which is independent of your cycle time. It's a set cyclic block. So we want to make sure that we are looking at the same data, and we're just going to say use max recording, record every cycle, and you look at this, it's about every 4 milliseconds. We're going to save that. We're going to download that to the processor, and then we are going to record that. And what you will see is we have a sawtooth wave, okay? And we're gonna stop it, and we're gonna talk about what this is. So we're gonna go through and zoom in on one of these, and you can see that the effect of the cogging that I was telling you about is there. So what this is representing is on our y-axis here is the position of our drive. So remember, I set my modulo to 360 degrees. That's why you never see anything over 360 degrees, because it's always rolling over. And so you see it, once it gets up to 360 degrees, it immediately jumps down to 0 and then starts just kind of wobbly. Remember, it's a crappy motor, but wobbly going up at a fixed speed, because we're jogging at 360 degrees per second. So we should be able to go in here and clear this out. And if this is at 0.9, this should be at 1.9, because we have 360 degrees per second. So that's how we're going to interpret this graph. We're going to come back to this here in a second, because we're going to be doing some gearing and camming and different things, and this is going to be the core graph that we're going to look at. So what you will see in these motion control systems is this sawtooth pattern: up, straight down, up, straight down, up, straight down. So if you increase speed, you will tighten up how many sawtooths you get per second. Because if we were to double this and say to go to 720 degrees per second, we would have 2 of these cycles in the same time period that we have here. No, that's a lot on screen, but fairly simple. Just wanted to make sure that kind of talk about that and everybody kind of understands that. What's up, Edward? We're back. And by the way, if y'all get annoyed by ads, like, let me know. YouTube has been like jacking with the ad scheme, and I don't know how it affects these live streams. So like, let me know. On the live streams, maybe I need to turn it down so there's not as many ad interruptions, but I'm still trying to figure that out. So we have got this, and now we still have our motor running back there. So what I want to do is to now create this real axis into a virtual axis. And so I'm gonna stop monitoring this. I'm gonna minimize that. And all we're gonna do, first thing we're gonna do actually, is we are going to turn this drive off. And we're gonna change in our configuration, in the general or the basic parameters of our technology object. We have a running motor set up exactly how we want it. We just click this virtual axis checkbox. We're gonna save, and then we're gonna download. Problem is it will not let you make this change while the processor is in run. So what we're gonna do is we're gonna hop over here. We're gonna click here. We're gonna go to online tools. You kind of hardly can barely see it. It's underneath my face right here. And then I'm gonna stop the processor. And then that way, when I come back over here and then download this change, it actually takes it. So compile, because if I didn't stop it right here, it would say, hey, guess what? You can't do this while it's running. And so I'm gonna click start module. And so it's now back in run. So now I wanna go do the exact same thing. I'm gonna enable this axis, and you can't hear it, but nothing happened back there. And then now I say jog forward, and nothing's going on. As you can see, look, nothing. So, but if I go to my same trace, the exact same trace, go online, and then activate the recording, what we'll see is, guess what? We still have this leading axis is moving virtually. So we're gonna stop this and look at this. We've like zoomed in. It's still 1.8 exactly, but look, all of that ripple that was there before because of the crappy motor is gone. This is a perfect signal. So a virtual axis gives you a perfect signal. And that is very important to realize, that when you are working with these multiple axes off of like a virtual master, you want to have as good of a signal as possible. Now, sometimes you can't avoid using a real axis as the leading axis, but if it is at all possible, it is better to give yourself a perfect virtual signal and then gear on and tie off of that. Because if you have a little bit of ripple in your signal here, in a second, we're gonna gear that real axis onto our leading axis. And so it might have a little bit of instability around this axis. Well, imagine if it was trying to follow a real axis, it would be putting the ripple onto a ripple. So you'd be adding ripple onto ripple. And so it would just not be good. So that's why we use a virtual axis if at all possible. there are definitely cases where you would need to use a real axis and look at the feedback from that real axis. And in those cases, you want to make sure that it is following as tightly as possible, because any error that you have in that system is going to compound and kind of make things real bad real fast. So I'm gonna take a little bit of break. So by the way, I have a new camera and I haven't quite figured out how to get the camera to not overheat. I've probably got some setting wrong on it, so it may just kind of crap out, and so we may lose my feed on this. I'll disable it and we'll continue on, let it cool off, and then I'll get it back going. But just know that if y'all see me kind of like frozen, but everything else is still going, it's just because my camera died. Yeah, so Ignatius is another one of the long-time chatters in chat, and I call him my general. He's my greatest general, because he's out there preaching the news of Siemens, and he's talking about a real packaging machine that he recorded from yesterday, and he's put it up into our Discord. We'll probably look at it. Let's see what we got here. Yeah, when you get that up, Ignatius, I'll see about putting it up here, because it is very, very cool to like look at different machines. May put that towards the end of the stream, because packaging machines are very much using these types of processes. You set your speed, like your line speed, with your virtual axis, and then your cutter, your wrapper, your labeler, all of those are geared all off of that master line speed. So all you're doing in this case, if we wanted to speed up 10 different axes, all we would have to do in our case that we're building up is change this value here. We would just have to increase that speed. So what we're going to do now is I'm going to go through and we're going to... That's loud. By the way, this is a shared warehouse space, so if it gets a little loud and you can hear stuff in the background. Oh, Ecuador, awesome. So Teddy's from Ecuador. I know Ignatius is from Africa. I think we've got some from Saudi Arabia. I know we have some chatters from Finland that's been in here a lot. Norway, Poland. A lot of those, and I know I've seen some like Singapore, maybe not Singapore, Thailand, and Southeast Asian as well. So let's go through, and what we're gonna do is add in now we're gonna add in a second technology object, and because we are going to be synchronizing these objects to this leading axis, we're going to make a new object. First of all, though, we have to disconnect physically from this mechanical system. We have to disconnect our configuration from here. So we're going to go to our drive, and what we're going to do is we're just going to select all and delete here. And because we have it's selected as a virtual axis, I've just removed the connection for the leading axis from our actual system. And so what we're going to be doing is making a new axis now. Yeah, so I'll show you here in just a second when we get the cam, when we get it geared in. We'll increase the speed. I'll show you the increasing of the speed. So we're going to create the follow, or we're going to call this real axis, because this is the real axis. And we're going to make it of a technology object, TO synchronous axis. And we're just going to make that. Oh, awesome. Mika. I never realized you were from Syria. That is awesome. we have some grease. Wow, that's awesome. Like I love the international crowd that we have here. So we're going to change this to a rotary axis. We want to set this up with the same modulo. It just makes life easier. You don't have to do that, but the default settings on like camming and stuff don't really work that well. You'd have to massage more, and if I was having to go through all of those different settings and everything, it would be a very long screen. So yeah, so I'm just looking over. By the way, I have this large screen over here that has all of my other different windows, and I've got Discord pulled up, and I see where Ignatius is uploading the videos and everything. But so what we're going to do here, we're going to go to our drive, select drive. Because I have it already set up, we're going to have to get to the standard Telegram 3, and that's it. Remember, last thing I said, we're going to disable following error just to make things easier. You're going to see, depending on when we activate the gearing with its basic functions or with its basic technology, then it can jump around. So that, again, just avoids some nuisance faults. And we're going, yeah, so that's all we need in the configuration. So what now we're going to do is we're going to create a new function call called real axis control. And I'm not a smart man. Always check to make sure that you actually are creating the block that you want. So we want a function call called real axis control. Okay, and we're gonna take and we're gonna have our setups. We're gonna go, and I know I'm blowing through this. I've done this many times before on other streams, and I talk about each one of these. But we're gonna do MC power, real MC power. Always name your blocks. So always name your blocks. And I know that sounds like so real, power, reset, home, and stop. So MC power, MC reset, real, MC set. Home, real MC home. And I'll show you here in a second where all of these data blocks are being created. If you're not familiar with what I'm doing here, I'm creating instances of these data blocks. You can make your own function blocks. It's pretty cool stuff. There's lots of things that you can do. Lots of videos that I've done. So this is MC, oh, I did halt. I want to do MC stop, and there's a specific reason why on this real axis I want MC stop. Because here's the thing, when you're working with camming or gearing and camming, dadgummit, I deleted the wrong one. MC halt, MC halt doesn't necessarily cancel a pending gear in move. So if you mess up your settings somehow and you're trying to gear in something or cam in and it doesn't quite work and it just sits there waiting, MC halt doesn't clear that move. And so you can get some faults and things like that. So use the MC stop if you're working with camming and gearing, because it can actually stop that pending gearing move. So now what we're going to do is we're going to populate these blocks. I'm going to get this out of the way. So I'm going to take and drag my real axis into all of these blocks. Now, I need to populate these enable signals. And so what now I'm going to do is I'm going to create Um, this, I'm just going to take and make a Control-C, Control-V of this DB4 here. I'm going to rename it. Let's see if I can do this offline. Nope, can't do it online. So I'm going to go offline real quick, because obviously I need to change this to real axis data. And I'm going to go into the properties of it and change general. I'm just going to click up here. It gives you the next available data block, and good to go. Then now we're going to download all this, because consistent downloads. Go in here. Awesome. We've got some awesome group here. India, Egypt, just great. I love it. Oh. Cannot be active state. Oops. So we're gonna go online. We're gonna go to our leading axis. Did I not? So I still have my leading axis going. So in terms of technology objects, a virtual axis might as well be a real axis, which is pretty cool because you can just flip that switch and change it from virtual to real. Lucid, you missed a lot. Not really. You missed me kind of going through the kind of introductory. We've got a couple of axes here. You missed me swapping a real axis, or sorry, a real axis to a virtual axis, and we're just now getting our setup back set up to where we are going to have a virtual leading axis, and it is going to be, of course, okay. I don't know why. I got a lot going on, so I'm overlooking stuff. So now maybe I can download this. And then we're gonna restart this. All right, so now we got these going. So we got real axis, we got enable, reset, stop, home, jog forward, jog, because we know we're gonna want those, right? So now we're gonna go into real axis control. If you notice how I'm doing this, I'm selecting my data block over in my left-hand side, so in the project tree, and then in my details view, I'm able to look inside that data block and drag and drop out of that details view. Pretty cool little spot. So NC power, so we're gonna put enable to the enable for it. We are going to MC reset, MC home, we're gonna home, MC stop, we're gonna stop. So I got it. Looks good, right? Dun, 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 dun. Stop, stop, home, home, reset, reset, reset power. All right, let's download this. Now, one thing to note is that we have not put into OB1, we made this FC, we have not put that FC into OB1, so let's drag that in, because otherwise our code will not execute. Now, hopefully, I haven't messed this up so much that we can go into, this is in our real axis data, and that didn't make sound. What we got going? Oh, come on. Pulse it out. Not coming on. Why is that not coming on? Real live, this shows you that Even oh, I know why. I gotta do this.
Ready? Ready?
There we go. Makes a sound now. All right, so we don't have a jog forward, but we've got control now. So that's all we need to do. Pretty quick. That only took, what, 10 minutes to set up that axis. So we've got our leading axis we're not going to be messing with anymore. I'm going to clean up a little bit my screen. We're not going to go into OB1 anymore. Our leading axis, we're not going to be doing anything anymore. We're working in the real axis. So let's go through now, and I will just want to get our jog block. Let's do our jog block just so that we can just show that how easy it is to get everything going here. Real jog, because we're going to want we want to get back to where we were before, and that should get us there. Is that gonna let? Yep, yeah, it'll let me do that because that's just code. So making changes to your actual technology object is kind of where you're having to start and stop the axes. But adding in just functions code to like FCs, FBs, that's just all runtime changes. So we're making big changes in runtime. So if you're not familiar with the power of Siemens and the fact that you can make a lot of changes just like at the snap of a finger with one download, it can catch you off guard how much you can change online. But so we're going to go through and look at the jog. That should be everything there. One thing to note, this position controlled on the jog, that's kind of important because in order to gear into something, we're going to want that position controlled move. Only problem with that position controlled move is it keeps up with following error. If you disable that, it doesn't keep up with the following error. Yes, Lucid, it's actual hardware. Like, you see it over in the, like right there? That's real stuff. Look, I'll show you. I'll prove it to you. We're gonna go into our real axis data, and then we're going to jog forward. And look at that. See that, Lucid? It's jogging. And if we want to turn that off, it stops. Jog it backwards. It's jogging backwards. So we're good to go there. So now we have complete control over our axis. So we've brought back to where we now have control over our real axis. We have ways of like messing around because I went through and tested everything yesterday, but I can always mess things up. So we have got, what are we gonna do? Our trace. Let's update our trace now because it's gonna be offline or not monitoring. Now we'll go to our signals. We'll go to, real axis now, and I want to do our same position. So actual position. Or am I missing it? There it is. We'll drag this in here. We're gonna download that. And so let's start recording. Get our leading axis. Let's get it going. Jog forward. Look at our trace. It's got some stuff going. Real axis. Jog forward. It's got some stuff. What's up, Rashanath? So, just random stuff, not synchronized, not anything. Okay, so let's go through and let's see if we can get these signals on the same trace, or the same value. Dang it! I should have looked this up, because if you're in chat and you know how to get these on the same what's it called? Because we want these overlapping on each other. How we get them on the same thing? Put that in there. So, so that is a good question. Position, the difference between position and actual position is not exactly sure. Oh, that's not it. Right here. What we have is the difference between the position and actual position. I'm not exactly sure. It's going to be something in the actual technology object. Sometimes that could be the position calculated by the technology object versus what is actually being read in by the encoder. It's middle of your taskbar icons. Superimpose in the middle of the taskbar icons. Group them together to overlap them. Shows you how much I use the chat. Oh, like do this. Like that. There we go. There we go. Ah, there we go. Ignatius got me there. All right, so this is the craziness that I wanted to show you. So now let's zoom in and see, even after many years, why are you not zooming in? So what we got is, yeah, I wanted to zoom to a very specific, it does not like this. But anyway, you can see that these are definitely not synchronized in any way. They're running at the same speed, but they are not running at the same synchronization. Because eventually they are synchronized, running at the same speed, they stay synced. But if I were to change, for example, my leading axis speed to double, and run this trace now, you would see that they would no longer be synchronized at all. And it would just be quite a mess. Why is it not letting me automatic range? There we go. So you can see that this is quite a mess. Quite a mess here. But you can see that our leading axis, which is the red, is moving twice as fast as our blue axis, the following axis. So, not belay that, or not go on any more with that. And if we want to speed up the real axis, we can do that here, 720. And you can see it moving faster over there. So, now, let's go through and do the next thing. I want to gear these together. I want these to actually be geared together. So what I'm going to do is I'm going to stop my real axis. Go here. We're going to stop this. Disable it. And then we're going to go into our real axis control, and we're going to forget about jog. And we are going to do gear in pause. So our new function that we're going to be bringing in is instructions, synchronous motion, gear in. So gear in is basically, it just runs the two axes at the same speed. And so it's kind of like a speed controlled sort of thing. Gear in position, we are using the position of it. That's why we have to have that jog function in position control mode, because we are going to be gearing in. So real MC gear in pause. So if you notice a difference between these two, you now have a master and a slave axis. One thing that we need to do though, that I forgot to do, is in the real axis, you have to allow, you have to tell what are possible options for this master axis. So if we were to just go through and say leading axis, real axis right now, this actually would complain. It would probably either fault out our processor, something, because this real axis is not configured with our leading value interconnection. We need to go and say add leading axis type of connection. For this, we can actually do an actual value because our leading axis is a real value. Or sorry, a virtual axis. So it's all virtual anyway. So we're gonna do that, actual value there. We're gonna save that and see if it'll let us download. Who knows if it will. Oh. Leading axis, oh. So right now it's complaining that this is on. So now let's download. What's up, friend? We have more members in chat. If you're not aware of what membership gets you, this, for our top tier membership, you will actually get this file to be able to play around with. Once we finish up this file at the end of the stream, I'm going to upload this into the member directory, and you will actually have access to this file as a member on the programmer level. Again, I talked about the fact that later on we're going to have the bonus content at the end of the stream. That will be available for all members at all levels, and there's some other things that all the members only videos and things like that I add in is available for members at both the supporter and programmer level. So one thing to note on that. So we did that. We added into our real axis the ability for it to follow the leading axis. So let's go back into this control and look at the settings of the gear in position. So gear in position has a little bit extra, a couple of extra settings versus just the regular gear in. So, and it's basically these master and slave sync position. Because we're gearing in based on the position, you can actually set, if you had two, like, look at this, if you had two things like this, you can actually say, I want my 0 position on this axis to sync up to the 0 position of this axis, and it'll go think and then start moving. So kind of cool there. So that's what this master sync position and slave sync position is. The thing about it is we can actually just use the default settings as long as our leading axis isn't going too fast. Then we can actually sync up. Bro. But so we got 360, and then let's get this going. Let's start that up. Should be jogging. Let's check our trace. And oh, probably because it needs to see. Let's just do this. Another way that you could go through and look at this is if you go to our leading axis, you go to the diagnostics, go online. You don't have to use a trace. Diagnostics, monitor motion status. You can see that the position set point is changing. You can see that the actual position is changing. So it is going. You don't have to use that trace function. Because when I grouped all those together, for some reason I can't zoom to a thing. Anyway, we're gonna do that. So let's this out. So now what we want to do is go to our real axis. So we need to be able to execute this. So let's go into our real axis data and create a value here. Add row called gear in. We want to make sure it's a Boolean. I'm gonna download that. It's gonna reinitialize. So reinitializing just means that all of the stuff in this block will go back to the default values. So now we have this gear in, and so we can go here, we're here, execute our gear in, download that change. You notice that's consistent download, no problem there. Now, we're gonna go back into our real axis data. We're gonna enable our axis. It's on, I can hear it. One thing about this though is we need to home our axis. So we have to have a home position. It has to know where it is. It has to be homed in order to be able to do this gear in. And so let's just try it. Let's try the gear in. And look at that. Woohoo! It's working. So now that it's geared in, let's look at this trace. And let's actually run this trace. Cool, right? So let's zoom in. And you can see that it should be pretty close. And it is. This is like annoying, isn't it? So you can see that it's actually pretty close. And you can see that it is lagging it a little bit. Let's go through here, and you don't have much. The difference between this, if we were to really be able to zoom in, hold on, let's zoom in really tight. Because you can see there is a little bit of ripple here. There's a little bit of a gap. And that gap is just the fact that you have a real axis that has its quirks, in this case, like decades of use. And it's not exactly able to follow it like as well as you probably would want to. And so that's what this little gap right here is. So that little gap between there and there, that is just the fact that it's a real axis. So one of the things about it though is you can see that it's pretty close to following. It looks like it's a lot here in that little spot there, but it's really not. It's really closely following. So what I want to do now is I want to go through and change. Let's change this slave sync position to say 90 degrees. I wonder if I can, and what this is doing is it's taking and putting in a phase shift into this, into it. And so it's still running, right? So let's see if we can do a positive edge. Let's make sure our trace is running. I want to capture this. So let's look and see if what we got here. Look at that. So you went in and it did a phase shift. So what you have is, I don't know why I can't, but you could see that on this, at this point, you could see where I actually executed the gear in, and somehow it was almost perfectly aligned. But what it did is it essentially moved that axis, the following axis, and shifted it back to where now when you go to 0 on the leading axis, it is at 90 degrees on the following axis. So it's pretty cool stuff there. So you're putting a 90-degree shift, and that is what a 90-degree shift looks. So you can see that it phased backwards 90 degrees. Okay? And if you were to change the master sync position, it would do the exact opposite. So if you were to say flip those and we change the master sync position to 90 degrees, it would take and put this crossing line of the slave, it would, instead of crossing here at 270 degrees, right? Yep. It would cross down here at 90. So wherever 90 degrees is, somewhere here. So it would cross the master axis at 90. So it would cross it here. So it would take, and if I were to flip those and re-fire that gear, it would shift this backwards to that. Now there's a lot of nuance into the settings of what's actually going on here. What direction are you shifting? And that is all in this little thing here called the where is it? This profile, sync profile reference. So this guy right here, this sync profile reference is stuff that like determines, okay, am I going to actually turn the motor backwards? Am I going to allow it to be able to speed up? How fast am I going to be accelerating? All of that is built into this sync profile reference right here. And so, what's up, Hans? So PLC skill tree. I don't know if y'all know this. Hans has one of the best YouTube channels for Siemens equipment and Siemens learning. Hans has got some great talent there. If you're not subscribed to PLC Skills Tree, go in there and subscribe to him. He has got a ton of experience, and he gets to work with very much cooler stuff than I do. He gets to work with like chocolate while I'm working with like chicken manure. So there's a little bit of jealousy there, but he's also got a much bigger channel than I do. So Hans, welcome to the stream. Sorry you can't stay, but honestly, anytime that you get to spend with your kids, I feel that's a better choice than sticking around at some nerd stream. But yeah, definitely PLC Skill Tree, great YouTube channel to subscribe to. Hans is there doing great work. But the sync profile reference, back to the gearing, is kind of like how the motion actually works. So if you go through, you can always click on this, click F1, and it pulls up the help file eventually. And I say that for some reason it didn't pull up the proper help file for this one. I don't think I had the right one. There you go. I didn't click in the right place, but it will actually tell you about what that sync profile is. So sync direction, sync profile reference. So It'll tell you about all that. So that's in the help files. Just click on your block, hit F1, and it pulls it up. So now that's camming, or not camming, that's gearing. And we are barely, we're like right on an hour in. Chat, like we might actually do this. Like this is awesome. I've got a meeting with a very cool Siemens technical guy here in Atlanta. Siemens USA is based out of Atlanta, and so I kind of have the advantage of being able to hang out with some of the guys there. But I'm meeting up with him at 1 o'clock, so I got to leave out of here at noon. So I want to make sure to get through all of this, and then we can chat about random stuff. So now we are going to add in camming. All right, y'all ready for it? So we talked about in a previous stream that in order to have camming, you need to have a camming technology object. So let's go through and do this first, because let's add a new object. We're gonna call it our demo cam. All right, and it is going to be a technology object cam, and we're going to open up this file, and what we're going to do is we're going to create just a real simple cam profile, and we're going to make a sine wave. So what I'm going to do is make this axis that's sitting back here turning geared on, which, by the way, I want to show you something. If you notice, I can turn off this gear in before we get away from this. I could turn off this gear in and it still moves. An MC halt would stop this motion, but if for some reason it doesn't gear in and it's kind of sitting there waiting to gear in, an MC halt will not stop that motion. So I'm gonna show you this. So MC stop will stop it. And then if we want to gear back in, should gear back in. All right. So MC stop actually physically stops your axis. And so we wanted to do that because we are going to be doing this demo cam, because what I want to do is I want to put a sine wave onto this motor. What that means is I want it to go oscillate back and forth from 90 to negative 90. So I want to oscillate it back and forth. So let's build a sine wave here. We're going to add a point, and you can do these and edit them by like the features up here, but I'm just going to do this because I know what point. My leading value is 0. My following value is 0, correct? That's how sine works. Add another point, and it will add in a transition. So at 90 degrees on my leading, at 90, not 900, at 90, I want it to be 90, right? And then 180, 270, yep. So at 90, I want it to be 90 degrees. At point did that at 90, I want it to be 90. Point 270, I want it to be negative 90. And then at point 360, I want it to be at 0.0. Okay, that looks right. It definitely did not take me a little while to figure out how to do that yesterday. So, so don't worry about your cam profile. You can absolutely go through and add in points and tweak these things. In a previous stream, in the bonus time, we kind of worked with these and kind of show how they tweaked out, kind of tweak all the things, and we maybe do that in a minute. But what what I just want to show you here is the process of making your cam and then making it to where your real axis can gear into your leading axis, and then follow this cam profile. So what we got here is a cam profile. It's good to go. We're going to download that to the system. Yeah, see, Ignatius, this is what happens when it takes me 2 months to get ready to do a stream. So the quality, much better. But I joke, but there was definitely a lot of stuff going on in the past 2 months that prevented me from even being here. So I'm glad to be back. But let's go now into our real axis function blocks or function call, and let's bring in the synchronous, or sorry, camming. So let's go into the cam function, and you notice, all right, yep, it's gone. So my face is gone for a minute. Probably gonna have to let that cool off, and my face will be back. But what I'll do is I will bring up a bigger block of this. So face is gone, but whatever, we got this. All right, so you don't need to see my face. So one thing you'll say, okay, you want this function mccam_in, and you can find that in synchronous motion. And you're very tempted to just say, hey, just bring this in, real cam in, and be like, oh, this is real simple. This is real good. All right, I've got my master is my leading axis, my slave is my real, my cam is my demo cam, and then, oh, I need to execute. And so let's go here. Let's add a new value, cam in. Download that. You're real tempted to just do this because, and the reason I know you're going to be real tempted to do it is because I did it for yesterday when I was preparing for this, and it doesn't work. This doesn't work, and I'll show you why. I'll show you what you get because I'll show you what you get so that you can see the error. So when it happens, you know what's going on. So is our leading axis still moving? Yep. Okay. So we've got this downloaded and ready to go. All right, that's on. And so you're like, okay, Jason, just like everything before, well, I will say I need a sync profile of 0 because you'll get a different, so if you have the default uses this master start distance here, and what that master start distance is how long you have in order to actually get moving and get going. So sync profile 0 just uses the default data in order to cam up, and it calculates everything and gets you going. So let's download that change and accept that. And then now, so we're going to get an error here. All right. And so I'm going to say cam in, and it did nothing. It didn't do what I thought it was going to do. Why did you not? Oh, because I'm stupid. You want to know why I'm stupid? I'm just so excited about this stream, chat. I didn't bring this over in here. I'm so excited to show you how it breaks that that I didn't tie that in. So all right, now so y'all may not be able to hear it, but it's sitting back there behind me making its obnoxious noises, and I'm gonna go cam in, and it's off. And you're like, what just happened? It just shut off. Well, let's go to the diagnostics on our real axis. So diagnostics and and we're going to say status and error bits. And look at that. We've got an error and it says user program. And it says you've done messed up, chat. That user program means that it's not something in the configuration. It's not something in the motion. It is something else in the user program. So what could we have in our user program, which is right here? Well, we have a cam that has not been interpolated. And I thought yesterday when I was working on this, I thought that it interpolated it when you compiled it. Well, chat, I was wrong. Real cam interpolation. And so what interpolation is just simply taking all of these points that we did on our cam, on our demo cam, and then this pink line is the interpolation. But really this cam just consists right now of 4 points. It hasn't actually been this pink line created. And so what we have to do is we have to link our demo cam to the cam. Then we're going to add in another value, interpolate cam, and we're going to download this. Except after we do this, because I want it to work. So we still got our leading axis should still be moving. Yep, it's still chucking along. Oops, didn't mean to close that, but whatever. So now we can go back and we can try to get all of this reset back up. So we don't have anything moving, so let's reset our axis. Let's enable our axis. And it is on, I can hear it back there. So what I need to do now is I'm gonna home my axis, and that's setting the 0 set point. Now, I'm going to interpolate this cam. And we can go here and see that it's done. It's done, chat. It worked. So now we could go back and hopefully when I click cam in, it starts working. And look at that. It kind of worked for a second. But what happened? Chat, what happened? Let's go to our real axis. Diagnostics. Let's stop our axis. Go here. Chat, why is it not working? Oh my gosh, my computer is dying a slow death. Interesting. What's going on, chat? Let's diagnose. Diagnostics on the leading axis, make sure it's still moving. It's almost like the leading axis stopped moving. No? It worked. Alright, let's go. Try this again. So we've got cam in. Oh, chat, I know what's going on. It's working, but we have our configuration on our cam is not configured correctly. So let's go to properties on our cam because is it here? Yeah. Supposed to be right here. Where is it? Because we have to set this up as a... Right here. Gosh, that's so annoying. So, optimization, interpolation. Where's that setting? Where's the setting, chat? So we have to set this up as a cyclic cam so that it actually continues to move. I don't know why this is not here. Again, I went through all of this yesterday and set everything up and deleted all of it because I wanted to impress you, stream. And this is what I get. My hubris. Oh my gosh. I'm glad you can't see my face because it's like shocked Pikachu. That's exactly what it is right now. Cat continuity. This is supposed to be... All of this is fine. All of this is fine. All of that's fine. Where's... Oh, come on. Where was that? Oh, I'm getting annoyed now because it was setting up. Oh, I know what it is. I apparently had... It's this MC cam in here. Let's go here because I forgot that there is another setting here, because what that cam did is it ran through one time and then that's it. Like, I want this to be a continuous cam. And so which one is this? Where is it? It is... What is it? Come on, chat. Where am I looking? Sync profile, synchronization using... Nope. 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 Application mode. There it is. My goodness, chat. Let's change that application mode to a 1. I forgot that I had done that. I knew there... Our application mode, this has to be here because everything was working perfectly, chat, until it wasn't. But, so now we're gonna download this. Now, let's go over here and we shouldn't have to... Chat, look at what we have. There you go. At the exact same time that my music ends. And so I'm gonna let y'all sit here and do that for a second, because I'm gonna bring back the I'm gonna bring back the full screen camera. So, because guess what, chat? This is absolutely what we're doing. So this is a cam. and this is actually running back and forth. Yes, it's so exciting. I know, and I know that there would be tons and tons of people that would look at this like, wow, it's going back and forth, but it's actually following following our cam, and that honestly is everything. Not everything. That's kind of the very basics of what you would need in order to get this camming function going. But I don't know. I'm proud of it, chat. Isn't it cool? Like, so the CPU model is a 1515 TF. You don't need for this type of automation, for this level, you don't need a 1515. They have a I think it's a 1511T processor or a 1510T processor, but you do need a T processor in order to do this automation, because the motion control, the advanced motion control features are only available on the T processor. Now, again, I'm not using any of the F, so that's the safety processor. You can see here it's yellow, but yeah. So the yeah. So what I would say is, yeah. So Lucid asked a really good question, and honestly, I got some time to actually go through and kind of modify this cam profile so that it actually looks like maybe something that Lucid is kind of talking about. So, like a stamping press is, let's kind of show what this does. So, a stamping press is like a big piece of equipment that you put some sort of mold in, like this, and then you have an axis that has kind of like a cylinder on it that is connected to this. So as this moves around like this would go down and then up, right? So this would go down and then up, right? So what we're going to do is we're going to change this cycle to, we're going to clear this, and we're going to make a stamping press cam. And we're going to change this cam into something that we're, I don't know, let's kind of work through it. And this is all kind of off the cuff. I haven't really played with this, but it is something that you would actually use it for. So what we're going to do is we're going to say that this stamping press is, let's see, let me draw this over here down in this bottom corner. So the stamping press, we're going to call this 0 degrees. And in the stamping world, this would be called top dead center. If you're a mechanical or a car guy, you know that there's top dead center as well. And you also have a totally different understanding of what a cam is. But a cam is doing this same thing. It's changing the valves. Like a cam in an engine is changing the valves. And it has these little rollers. And depending on the shape of the actual cam shaft, then your rollers for your valves will sit and ride, and those valves will open and close based on that cam. Anyway, let's talk about stamping press. So what we want to do is this is going to be 180 degrees. And what 180 degrees, what we want to design is a stamping process that is called a pendulum process. And so we want it to go down to 180 degrees. We want to go down to 180 degrees and then back up to 0. Okay, so let's modify this profile here. So as it rotates through at 180, we actually want this to be at 180. So halfway through, we want this to be at 180. So at 180, we want this to be at 180. Okay. Doesn't really show the... Is there a way that I can just like zoom out without... Okay. So it's going to go up to at 180. We wanted 180. And now, obviously, that doesn't quite work. And then back at 360, we want it to go to... So we're going to delete... We're actually going to delete this point because we don't need it. At 360, we want it at 0. So that, I know this looks really like rudimentary, but this is actually how you could do a pendulum style stamping press, to where you're going down and you're not carrying all the way through. And so this would be a hit and back up. So let's go there, and then now let's go back to our real axis data. And unfortunately, my screen, if y'all are chatting, can't really see behind me when I'm using my tablet. So I'm sorry if I'm not paying attention. But so we want to interpolate this cam, and then let's see what it does. If it's in the middle of a cam and I want to put it on a different cam, I'm going to do that now. Nothing. Okay, so what I'm going to have to do is I'm going to have to stop. I'm going to do a reset. I probably don't have to reset, and then I'm going to cam back in. And so it actually may have been the same, because I've realized that I'm doing a 180 degree shift. And so just the ever so slight difference in it, I probably just couldn't notice it, but it's doing the same thing. This cam action, to where I'm only going to 180 degrees, you can kind of follow it. Let's pull up the screen to the workbench here. You can kind of follow that, like if you were looking at that top line. I guess it kind of works better from if you're looking at it from the perspective of like horizontal. But yeah, so it goes from horizontal, goes 180 degrees, back and forth, back and forth. Now, let's go through and let's change this up to where there is, go back to here. Let's go back here, and let's change this up to where there's a little bit of dwell. So when it hits at that 180, it actually, we want it to dwell for a little bit. So let's add in another point like here. And then I want to actually move this point back some. So I'm going to take and grab this point and just move it back to where in our cycle, so from about 160, and then I want to add in another point because I don't want it to go over 180. I want it to stop at 180 and dwell. So what we're going to do, we're going to add in another point back here. And so let's tweak these at point 160. I want it at 180. At 180. I want it at 180. At point 200. I want it at 180. All right, so this would be a stamping press with a pendulum style stamping press with a dwell. And so this would be like, if you're putting enough pressure on that material, it's actually going to sit there and deform the material. And some materials you want to have a dwell time, some materials you can just do a simple hit. And so now let's go through and we're going to download that change. We're going to accept, and we should be able to tell the difference pretty significantly. Let's interpolate this cam. And let's see if it cams in onto the new cam. I can't tell. All right, so let's see what our trace looks like on this. So this looks like it's still doing that original cam, doesn't it? Yeah, it looks like it's doing that original cam. So we probably need to do the cam out function. Because you can see that it's doing this 180, negative 180 sort of thing. So let's go through and let's see if we can get this thing cammed out. What we'll do is I want to go into this cam out. Go back here. So there's a synchronous motion. And so there is cam out. And I'm pretty sure that I need to do this. So real cam out. And then, so it's the slave axis. This, we'll see. So let's look at this. So save. And it might be I might be doing these out of order. So let's go through and add in another here. Let's just do this right here. Whoops. So unprofessional of me. I'm sorry. Cam out. Okay, we're doing this. All right. So now let's download. Because it might be that interpolate cam doesn't work if it's like in motion or whatever. So we got that. Everything. Oh, because yeah, we redid this. So let's reset this. Let's cam out. Let's look at our demo cam. Let's compile that. Didn't need a download. Apparently it does need a download. Let's go back here. Let's look at this. Execute. All right, let's go to real axis. Let's interpolate the cam. Make sure that it says done. Okay. So now let's enable and then cam in. There we go. That's what it was. All right, chat. That was all it was just that we kind of did it out of order. We have to cam out, and so you can see now. Let's go to the workbench. Let's go to the workbench screen. So you can see now it's accelerating to the thing a little bit quicker, and so it's speeding down to it, and then sitting, and then dwelling, and so that's kind of the motion that you have here. And so if you were to actually go through, and we'll swap back over here to Portal. Actually, I'm probably gonna include this portion in the stream. So psych for all of those that we because that took a lot less time than I thought it would, and so just yeah, I'm gonna actually include this in the stream. So yeah, I'm gonna kind of do my outro and everything again. So if you haven't liked and subscribed, you should. And we've got memberships. Join the Discord. We've got all of this. I'm gonna go into bonus time to where we're gonna be talking about stuff that has nothing to do with the yeah, it has nothing to do with the topic at hand. We're going to be talking about some Modbus stuff, maybe some general topics about electronics, and mostly stuff from the Discord, and then the Discord server, and then we have a couple of comments from someone out of France actually asking about Modbus. So until next time, I will catch y'all later. We're going to start up the bonus time. Forget about all that stuff from earlier from the people that were on stream. Like, I didn't realize that was going to be that quick. So, yeah, catch y'all later. Bonus time is starting here in a second. If you don't have the bonus time, you weren't quick enough. You have to catch us live or within a week. Catch y'all later.